Thank you. Um, Hope you all can understand my accent. I also kind of talk with my hands, so I may be going in and out and getting louder from all that, and I apologize from the get-go. My talk today is kind of talking about beneficial reuse of produced water, just kind of an overview of what the industry's doing. A lot of what we're doing is in the Permian Basin, but that doesn't mean it can't be brought up here into the North Dakota area to kind of do the same thing. And it is not really talking about reclamation, which I know this conference is, but in a way, we are reclaiming the water to be reused inside the oil field and looking at the ability to use it outside. So I'm going to kind of go off a quick introduction to Select, talk about reuse and the offset, or reuse to offset the freshwater use in the oil and gas industry, kind of where we are in the reuse outside the oil industry, kind of talking about the common technologies, the treatment cost and performances, power requirements, the potential waste that you do. I mean, every time you do this, you create waste, and then obstacles that we currently see in the beneficial reuse outside the oil field. So quickly about the Select Water is the only company industry to have an integrated full life cycle of water and chemical solution. So, I mean, what we do is just about touch anything that has to deal with water except for pumping the water down for a stimulation job. We have water sourcing for fresh water. We source produced water to supply for the frac jobs. We supply chemicals to the frac jobs themselves through our chemical side of it. We have flow back and well testing. We do fluids hauling. We've got pipelines to dispose of the water, SWDs, and we do solid waste up here in North Dakota. So you may all know some of the solid waste. So that does come into the part for the remediation part from it. So we've got over 25 SWD wells in the North Dakota, Montana area to dispose of the produced water. We also have some water pipelines in this particular case that's all fresh water pipelines to supply water for the stimulation jobs. So one of the ways, and there's multiple ways of being able to reuse water in the oil field or oil and gas operations. The one that we've kind of focused in on is you bring the raw produced water in from the oil and gas operations. You run it through another oil water separator. It's no different than what's being done on any of the SWDs or on location itself. We put it into a above ground storage tank, just kind of give it a wide spot in the road to be able to just kind of have that spot to smooth out any inflows and outflows from that. We add oxidizer, coag to the produced water itself. That way we can get rid of any of the iron and be able to bring the suspended solids. Then we run it through a dissolved air flotation system. And after that's done, we put it into some type of produced water storage. You can see down below, this is one of our operations in the Permian Basin. It has enough to be able to process 60,000 barrels of water a day. We've got 3 million barrel pits on the backside, so we're storing 3 million barrels of produced water. In this particular case, the main reasons that we are working through and processing the waters to get rid of the suspended solids. If you let the suspended solids get into those pits, they become septic and produce H2S. So it's more of a storage part. There's other operators that actually skip all this part with the oil water separations. They take that raw produced water, send it straight to the frac job and frac with it. The chemistry's changed over the years, and we're able to reduce the friction or have friction reducers that actually work with the high TDS waters, even the high TDS waters we see up here, to be able to do that. So over the years, everything's changed, and it's like everything here, you know, if there's a need, somebody's going to figure out how to actually solve those type of issues. So that, like I said, that's one of many ways it's reused in oil and gas operations. So some of the parts there, and that's what a lot of people ask is, what can we do if we are actually going to take it outside the oil and gas industry? What beneficial reuse can we actually do? Potential uses for this is one, construction. Use it for cement. We can do it for irrigation or non-consumable crops. So there's, I'll touch on it a little bit later, but a lot of people always go, well, we can't reuse produced water outside the oil and gas industry on irrigatable crops because they're worried about what is actually in it after you process all that part of it. You can do irrigation for golf courses, road maintenance on the non-paved roads. And one of the big ones there is the energy transition. A lot of what's not talked about is how much water's actually going to be needed for blue hydrogen or green hydrogen. It's very water intensive from all that part of it. So that could be a possibility of doing that. The IRA of 2020, put some potential 10-year credits for hydrogen production. And, that's one of the possible operations that we can use this produced water in. So some of the common technologies out there that is used from this, first one's reverse osmosis. It basically uses pressure to push water molecules through a permeable membrane. It does need some extensive pre-treatment needed beforehand. It does remove all the minerals and salts. And one of the things that we're seeing here as we're processing or looking at that is the water's almost too clean. It's interesting that we have to take out all these minerals from that to meet that, but then I actually have to add in minerals back in to be able to put it back on the soil. Kind of like with the last talk, you're trying to get rid of some of the minerals that are already in there, but if it's too clean, you'll actually be washing away chemicals or the minerals that are already in your soil or in the water itself. Some of the bad parts that come here is it's easy to foul the media, and once the media is fouled, you have to actually get rid of the media and start over. And the other part, it's really limited to about 50,000 TDS. There are some papers and discussions about being able to step it down in about 50,000 TDS increments, but every time you step that down with reverse osmosis, that's additional capital that you have to spend to be able to do that. The next one is vacuum distillation or mechanical vapor recovery. Again, you've got to remove your hydrocarbons, your total suspended solids, iron, and divalent cations. You have to remove those because they'll actually scale up all your equipment from all that part of it. It's also very energy intensive. It also takes high temperature systems. It's a high temperature system with a very high brine concentration, so you actually have to have corrosion resistant alloys. So that again increases your capital cost to be able to do that. And in this particular case, you have a freshwater stream and a concentrated brine. So one of the waste stream is, what do you do with the concentrated brine? Usually the brine somewhere about a 10 pound per gallon, probably about what your TDS of the water up here in North Dakota is one of the brines that you have to worry about either getting rid of, disposing of, or handling from all that. The vacuum distillation mechanical vapor recompression is one of the first ones that was actually used with oil field brines to make the fresh water. So that's been going on, or had a system about 12 years ago that was redoing this, mainly in the Barnett Shale in the Fort Worth area. The other one's a brine concentrator and crystallizer. It requires, again, pre-treatment to remove the hydrocarbons, total suspended solids, iron and divalent cations. Again, another energy intensive part, has the exact same problems as the mechanical vapor recovery part. And if you take it all the way to the crystallization, you now have to get rid of the salts. So, a lot of people go, well, what we'll be able to do is bring the fresh water out, and then we'll be able to process and sell the salt for salt and swimming pools, a bunch of other parts that keep doing that, but we would overwhelm the salt market if we actually started to do that. And it wouldn't take very much of the oil field brine to actually do that. It's amazing how much waste you'd actually generate if you took it all the way to crystallization. Probably one of the most interesting one that's really starting to get traction in the oil field side is the membrane distillation process. So this is a little bit different here. The membrane is a little bit more resistant to fouling than your reverse osmosis part, but oil removal is still paramount. You've got to remove the oil from there. This one actually has lower energy demand compared to the reverse osmosis part, and you can actually use the high TDS brines. So you don't pull out as much water, but you actually can use the high TDS brine. So it's TDS independent from there. Most of the other ones are heat source agnostic. This one's actually a low heat one. A lot of times you only need it to bring it up to about 120 degrees Fahrenheit, just enough to have a driving force between both sides from that. And the other part there is you actually have potential to provide recovery of a distillation unit at the cost of an RO. So you can actually have this for about the price of an RO. Like I mentioned before, the RO problem is that it's only good to about 50,000 TDS. Anything above that is not currently operational. Now, if we start talking about power demand, so if we look at the vapor recovery, mechanical vapor recovery, zero liquid discharge plants, you generally need 6 to 8 kilowatts per barrel of water processed. So we kind of look at that. If we look at it, 50,000 barrel per day plant, we use about 109 to 146 gigawatts per year. Average household consumption is about 10,500 kilowatts per hour. This is looking at the information from the Energy Information Association. The average household in North Dakota has 2.31 people. So a single 50,000 barrel a day plant would have the energy demand of a city with a population of 25 to 32,000 people. So that's just one plant to be able to process 50,000 barrels of water a day. Of that, up here, you'd probably only get about a 30% recovery. So you're talking off there that it's only 30,000 barrels of water that you'd actually be able to, and I did that math wrong, sorry, about 20,000 barrels of water a day that you'd actually be able to use outside that. Another 30 would actually have to be put down a disposal well used elsewhere. So they are very power demanding. Again, looking at the economics from all that part, the bottom scale off there talks about the total dissolved solids, your cost per barrel, and one of the parts that is actually holding back the industry from doing is the cost. It's a lot cost prohibitive to do that. Doesn't compare to what we're currently doing from that. Technically advisable, technically easy to do from that, but as you can see, we're talking about the VD and MVR somewhere about $3.50 to $6 a barrel. The crystallization's up there 7 to 12. And the membrane is, in that range from there, but we're still talking about $2 per barrel for the membrane distillation part. I kind of hit on this one part here a little bit earlier, but if we start looking at what's generated or waste that's actually generated off from all that part. So this is actually based on a typical composition produced water that is high in salinity. And don't ask me what high salinity is because I didn't do this chart. So 5,000 barrels of water a day, you'd have 53 tons of filter cake a day, getting rid of the suspended solids. You'd have about 4,000 barrels of distillate, 107 tons of salt, and 1,000 barrels per day of the calcium brine part there. So, as it goes up, it's an awful lot of salt if you take it all to crystallization. So as I said, there's been a lot of focus on beneficial reuse. We've been talking about this. I've looked at it for the past 10 years. One of the gentlemen that works for me has been talking about trying to do this outside the oil field for the past 20 years. So there's been a lot of interest in trying to figure out how we can reuse this produced water. So some of the corporations or industry parts that's doing it is, one of the first ones is from the federal side, is there's an alliance called the National Alliance of Water Innovation, or NAWI. They are looking at how to be able to reuse produced water outside the oil field. They're actually looking at it from a global part for water security within the U.S. So it's just not produced water. It is all types of brine recovery, how to, even municipal water, how to make that a lot more cost effective from there. On the state side, New Mexico has the Produced Water Research Consortium, which has worked with the NMED, which is New Mexico Energy Development, and the New Mexico State University. And they're also looking at how to put that into their strategic water supply. So New Mexico is looking at, how can they use produced water to help bring other industries into where, there's not all the water available from all that part. Texas has the Produced Water Consortium, which is working through the Texas Tech University, and they also look at it from the State Water Fund and how to help research from that. And Colorado has stood up the Produced Water Consortium. So New Mexico, Texas, and Colorado are all trying to come up with some type of solution. So, that kind of helps you guys. They're spending the money to try to be able to bring it up here for you to do that. So we actually look at what the current federal regulations are. There are a few that we have to follow. So one of the first one here is there's a moratorium against discharge of unconventional produced waters to the waters of the U.S. through a publicly owned treatment work. So a few years ago, or quite a few years ago, what they were doing is actually taking the produced water, putting it into a public water treatments, dilution's your friend, and being able to dilute down the produced water, and it went directly into that. About the time the U.S. government said, hey, you can't do that, the industry had stopped doing that already. So they put this moratorium in after we had said, yeah, that's probably not what we should do. You can take the produced water and discharge it to the waters of the U.S. through a commercial treatment works, but you have to get an MPDS permit from the either the EPA, or if it's handled through the state to be able to do that. And so far, these have been fairly rare to actually have one. There's probably, as I know from all that part of it, 3 or 4 that's ever been granted to be able to do that. And also the Clean Water Act, Part 435E, if you're west of the 98th meridian, you can actually discharge that into the waters of the U.S. if it can be classified beneficial for wildlife and agriculture. And again, it varies from the state or EPA. So, one of the best examples of all this part is the coal bed methane water actually uses this to be able to discharge that water. But my understanding is that water's pretty clean, and you just have to make sure the oil's out of it. There's not much processing going on from all that. So, some of the obstacles to beneficial reuse from all that. Well, a lot of times what we hear from here is we don't know what's in the produced water. We can't test for, all the chemicals that are in the high TDS water, because there is a lack of analytical techniques from high TDS matrix. But my argument back from all that part is I don't really care what's in the water that's coming into the plant. What I care about is what I'm getting ready to discharge. We can test for that. We have all the analytical properties, all the analytical tests to actually test the low TDS water. So let's focus in on all that part of it. If it carries through, we'll know it from the other side. We'll say, well, if it's on this side of it, it's on the other side. Okay, we'll figure out what to do from all that part. The other one's liability. Everyone says, produced water has always been classified as a waste. You're here, it's a hazardous waste. It's not a hazardous waste according to the regulations, but that is what everybody says. So, what's the liability? If we clean this water up and put it in there, they're going to go after whoever has the most money if they think something's happened that. I don't know what the rules are up in North Dakota, but there's question of the ownership of the water itself. Can you actually clean it up and be able to reuse that part of it there? That's some questions in Texas and New Mexico as to who actually owns the water and how you can do that. Part of it is permitting for smaller and portable systems. One of the parts that I always thought we'd be able to do is we'll be able to go out and clean the water up on small little, well sites. They may be doing 10,000 barrels of water a day, save money of having to put in a bigger pipeline. take that peak production off from all that. But there's not a part that's not possible to do that under the current regulations. To be able to get a discharge permit, it's just cost effective. It's drives you to doing the bigger, 20,000, 40, 50, 100,000 barrel of water a day plants from there. And the other part here, which kind of comes back to the liability, is public perception. What is the end use of the treated effluent? So I think I've kind of hit everything on here, and I think I'm plenty time ahead of all this. So, I kind of hit on, who Select is, reuse to offset freshwater use and reuse outside of the oil and gas industry from all this part of it there. So.